Welcome, everyone. I'm glad I made it because my doctor's appointment went overboard. I've had a bad cold and didn't want it to go further. Anyway, welcome to you all. I made it in the stitch in time makes nine or something like that. Um, I'm happy to present and introduce Lori Dengler, who's an emeritus professor of geology at Cal Poly Humboldt and an expert in tsunami and earthquake hazards. Recognized by Cal Poly's Humboldt Scholars of the Year in 2008 and should be undoubtedly again. And the recipient of a number of honors, most recently by the Humboldt League of Women Voters in 2024 as a Civic Contributor. Since retiring in 2015, she continues to work on North Coast earthquake and tsunami preparedness efforts through the Redwood Coast Tsunami Work Group, and nationally is a member of NOAA's Tsunami Science Technology Advisory Panel. She writes the weekly Not My Fault column in the Times Standard, and we're delighted to have you here. And you always have very interesting talks, and I love reading your articles. So welcome aboard, Lori.
Thank you, Jane. I hope everybody can hear me. I'm fortunate in that Mother Nature always provides something interesting and sometimes unusual for me to talk about. And so today I am going to talk about a monster earthquake that happened last summer, July 29th, magnitude 8.8 earthquake in Kamchatka over there in the northwestern Pacific. Um, and that earthquake triggered a tsunami warning that many of you may have received notification of on your cell phone. So, just a brief overview. I'll talk about the earthquake, why that earthquake happened where it did, and past earthquakes in that area. One of the really interesting things about this particular event was that there were smaller earthquakes beforehand, namely what we call foreshocks. Um, then we'll talk about how the tsunami warning system works, the July 29th main shock, spend a fair amount of time going through those tsunami alerts, what went right, and definitely areas to improve. Mitigation pays off, especially it did in Russia's Kamchatka Peninsula and the Kuril Islands. Some really intriguing new research that I hope will improve our tsunami warning system. And then, of course, lessons for Cascadia. However, before we jump into Kamchatka, I want to remind all of you that this is California's Tsunami Preparedness Week. And it's a time where we really try to focus on learning about tsunamis, learning about areas that are safe, and areas where all bets are off. And Humboldt, Del Norte, and Mendocino counties have kind of led efforts in California for quite some time. Not too surprising because we actually have experienced a number of events recently. The highlight of this week is the North Coast Tsunami Drill on Wednesday, March 25th. And I hope all of you will receive notification on your cell phones from the Humboldt or Mendocino or Del Norte County notification system that the drill is on. Basically, that's the only notification that you will get. There will be no sirens, no emergency alert broadcasts, just that county notification. And if you aren't signed up to receive county notifications, you might not get anything. Now, I really suggest either calling your county Office of Emergency Services or going to the website for, say, Humboldt County Emergency Notification and making sure you're signed up. This is how you can get alerts when there are fire evacuations ordered, chemical spills, other sorts of things that you might really want to know about before they reach your door. So check to make sure that you're signed up. On Wednesday, March 25th at 11 a.m., what we really want people to do is first know your zone. Are you in a tsunami hazard zone? It turns out most of the county is not. If you are in the zone, this is the time to practice how to evacuate. The good thing about Humboldt and most of the North Coast is that you can easily walk out of the tsunami zone um, in less than 10 minutes. But it's hard to do that if you haven't prepared ahead of time. So now is a really good time to practice your evacuation. And hopefully later on in this talk, you'll understand why we really want you to go on foot. If you are not in a tsunami zone, like I am, I'm a good mile away. I'm probably 2 miles away from the tsunami zone. Do like me and stay where you are. But it's a really good time to think about what you would do. Like this morning, I was at Molell on my dog walk, and I'm always kind of thinking, oh, there's the high dune. That's where I'm going to go in order to make sure that you and your family are safe. To find out if you are in a tsunami hazard zone, we've made it pretty easy. You can go online to the Redwood Coast Tsunami Workgroup page, basically rctwg.humboldt.edu, and right away you will see this screen. And the very first item on the menu is Know Your Zone. So if you just click on that, that will take you to our tsunami hazard maps, where you can find maps for particular communities, an interactive map where you can insert your particular address and find out where the tsunami zone is and where you are. Green areas are safe in even the largest tsunami events. Well, with one caveat, asteroids are out. I'm sorry, we can't protect you from asteroids, but everything else, tectonic, volcanic, that is included in these hazard zones. And they're all based on the worst event. So tsunamis like we've been having recently are not even going to come near to flooding the hazardous area. Okay, let's jump into Kamchatka. I was sitting at my desk at 4:24 p.m., actually studying a little north coast. We'd had a magnitude 4 earthquake about 5 minutes earlier, so I was paying attention to that when I got the first notice of this much larger earthquake, although that first notice had it only as a magnitude 8. 4:24 p.m. Pacific Daylight Time, which was also 23:24 Universal Time, 11:24 a.m. local time in Kamchatka. One of the things that gets very confusing in the tsunami warning world is that tsunamis cross lots of time zones. And so in this talk, I will generally be using Pacific Daylight Time, the time that most of you probably were experiencing. So this is a map put together by the U.S. Geological Survey that shows the epicenter, namely the star, the point at where the rupture began. But then it continued to rupture over 250 miles. There's some discussion still that it may have been a little longer rupture, to the southwest direction. And if you look at this little insert over here on the this blow up over here on the right, you can see this sort of elongated shape. That's roughly the rupture area. I've also noted 2 particular locations: the city of Petropavlovsk-Kamchatsky and I'll just call it Petropavlovsk because the whole name is a little too long, and the town of Severokurilissk. Petropavlovsk is the largest city in the Kamchatka area. This is all part of Russia. And it currently has a population of about 160,000 people. Pretty big city. Severokurilissk is the largest community in Russia's Kuril Islands, the chain that extends all the way down to Hokkaido, Japan. And it currently has a population of just under 2,500 people. It took a while to rupture that whole fault. 190 seconds, so that's just over 3 minutes. One of the things that really characterizes these large earthquakes is the long duration of shaking. So if you had been in Kamchatka or the Kuril Islands, you would have experienced probably closer to 4 minutes of ground shaking. So the whole time that rupture is breaking, is moving, it's producing seismic waves. And hence, when we say long duration shaking, and it's going to be longer than anything you've ever experienced, that's what we're talking about. We're talking about minutes of shaking, and that's an important warning sign for a very large earthquake. Let me put this in what we call a tectonic perspective. These earthquakes are caused by our mobile surface. The outermost part of the earth is constantly reshaping itself. We call these sort of chunks of the surface plates, and they're moving relative to one another. In some cases, they're moving side by side, like along the San Andreas Fault. In other places, they're moving apart, like along ocean ridges and in the middle of Iceland. And in the Pacific Basin, most of the rim of the Pacific is what we call subduction zones or convergent boundaries. And they're shown by, geologists like to show it with these little teeth, this line with the little teeth. And the teeth are pointing in the direction that the plate is moving. In this case, the Pacific plate is going under the North American plate. Over here in Kamchatka, the Pacific plate is once again going under North American plate, although sometimes people call this a little subplate here, and so forth. So the Kuril Kamchatka Trench is one of the most seismically active places in the world because this convergence rate is over 3 inches per year. It's one of the areas on the planet where the two plates are moving together at the fastest clip. So, not surprisingly, we have a lot of earthquakes in the Kuril Kamchatka Trench. And here's just a little snapshot of some of the bigger ones. These are all magnitude 8 or larger earthquakes, most of them in the 20th century, although you'll see that we have listed one in 1782, good evidence for 1841. And there are accounts of an earthquake back in 1737 that may have been bigger than any of these, though we won't know for sure because we didn't have any seismograms then. Could have been as large as 9.3. Most of these earthquakes are clustered close to the trench and are relatively shallow. That's because most of our big earthquakes are shallow, but there's a very interesting exception over here. This 8.3 in 2013 is the largest magnitude deep earthquake, over 300 miles beneath the surface. And it didn't do any damage, but it's really interesting to us seismologists. So here is the 8.8, very close to a 1952 earthquake that was magnitude 9.0 in terms of its location and close to it in size. I'm going to talk a little bit more about 1952 because it was a pretty major earthquake, caused large loss of life, and has certainly similarities and some differences to what happened in July. So we call this the Great Severo-Kurilisk earthquake, and it occurred on November 4th, and it caused the most damage to the town of Severo-Kurilisk, where we don't know for sure how many people died. The casualty number that's listed in the Geophysical Data Center's historic database is 10,000. Now, that seems a little unusual because at that time there were only 4,000 people listed as permanent residents. But all earthquakes occur in a historic context. And 1952 was the middle of the Korean War. And there were many Koreans that had flocked to this little island to escape the war. And unfortunately, many of the victims were probably those Korean refugees, hence that number of close to 10,000. It absolutely destroyed the town of Severo-Kurilisk. That tsunami was recorded throughout the Pacific. These big earthquakes create what we call trans-Pacific or Pacific-wide tsunamis. And certainly 1960 is an example. The Japan earthquake in 2011 is an example. And the earthquake that happened in July is an example. It was 17 feet high, that tsunami on the north shore of Oahu. And damage in Hawaii was in excess of 1 million. There was damage in California, including 4 boats that were sunk in Crescent Harbor. We'll get back to Crescent City a little later on. And there was damage in Santa Cruz. One of the interesting things about this earthquake and tsunami is it was the first real test of the fledgling US Tsunami Warning Center. So after the 1946 tsunami that killed over 160 people, mainly in Japan, mainly in Hawaii, the US formed the first Tsunami Warning Center, and it went into full-scale operation in 1949. So this is the first real test of that system, of being able to locate, estimate the size of the earthquake hours before it actually reached the coast, and evacuate people in harm's way. The tsunami was very large in Hawaii, but there were no injuries and no deaths. So it's certainly considered a successful launch. One of the really interesting aspects of this earthquake and tsunami is what happened in this town of Severo-Kurilisk. And here I've got a Google Earth blow up of where the harbor is and the location of the town today. But if you zoom into this square, you can see the streets of where the town used to be. And not surprising, it didn't do quite as well in 1952. Now, it is true that the 52 tsunami was larger, but not that much larger. And this area was all flooded again last summer. So they rebuilt the town away from the coast and at higher elevation. And it's also important to note that everyone there still remembers 1952. Many of them have relatives that were directly affected. And so it's part of the cultural memory, which is a really good way of educating communities to tsunami threats. You actually remember real ones. So let's prepare the stage for July 29th. And as I say, there are always large earthquakes in the Kamchatka region. Magnitude sixes and sevens occur all the time. But it really looks like the current sequence may have started back in 2024. Now, the 1952 earthquake was actually preceded by an elevated rate of earthquake activity for nearly 2 years beforehand. We call these foreshocks. And so, whenever you have magnitude sevens in this area, it's always useful to think, well, maybe this is a foreshock to something bigger. So, there were three earthquakes, one seven and two sixes that occurred over a year beforehand. But the rate of activity, aftershocks from this, was pretty much normal. I mean, there were fours and fives, but not at an elevated rate. In June, we've got a magnitude six. And then on July 20th, we have a 7.4. So, and at this point, after this July 20th earthquake, the rate of aftershock seems to be, quote, higher than average, at least according to some scientists. I wasn't thinking anything about it. I was like, 7.4, Kamchatka, no big deal. The 7.4 earthquake was large enough to trigger tsunami bulletins in the Pacific. And certainly in areas nearby, a 7.4 is capable of producing a modest tsunami. This earthquake was certainly large enough to be felt at the city of Petropavlovsk. There was some minor damage reported in the Petropavlovsk area. And there were a series of tsunami alerts issued. The Pacific Tsunami Warning Center initially estimated it at only a magnitude 7 and said, that's not going to be big enough to produce a damaging tsunami. But then just under a half hour later, they revised the magnitude. And this often happens with big earthquakes because it turns out a bigger earthquake is harder to get a good handle on the magnitude than a smaller one. The magnitude was boosted to 7.4. And at that point, basically larger than a 7.1, it triggers, in this case, the kinds of messages to foreign countries are called threat messages to coastlines within just under 200 miles of the epicenter. So that includes the Russian coasts of Kamchatka, the Kuril Islands, and northernmost Japan. This earthquake did produce a tsunami. And fortunately, we have a lot of deep ocean instruments. All these yellow triangles are part of what we call the DART program, the deep ocean assessment in real time of tsunamis. And these are pressure sensors that sit on the seafloor. And as the water height increases or decreases, it actually weighs that change. And so you can see a detail of the DART record, the instrument that was right here, very close to the epicenter. And the green line here is the normal tidal variation. This would have been high tide here. So it was on a rising tide. And the first jiggles are relatively sharp, and they're caused by the seismic surface waves. So earthquakes produce a lot of different kinds of seismic signals, And one of those types of signals we call Rayleigh wave actually causes up and down long period deformation of the Earth's surface. And if there's an ocean above it, it joggles the ocean. So these red signals right here are the surface waves. And then it's followed by this longer series of jiggles, and that's the tsunami. So it's a great system because it allows you very quickly to confirm, did a tsunami actually get generated? How big was it? And then you can model what the likely effects will be elsewhere. So very quickly, it was clear there was a tsunami. It wasn't a major event. And in less than 3 hours, the alert was canceled. Now, over on our side of the Pacific, the National Tsunami Warning Center in Palmer, Alaska, quickly determined that even though they got a bigger initial magnitude, this was not going to affect their area of interest. So we didn't get any kind of alert for that event. Now, what happened on the 24th is a good example of how on the 20th, on July 20th was a 7.4 foreshock, turned out to be a foreshock. It illustrates how complex our tsunami warning system is. We have two tsunami warning centers. There are other countries have tsunami warning centers as well, but I'm just going to focus on the US. So here outlined in red is the purview of the National Tsunami Warning Center in Palmer, Alaska. So we only should be paying attention to the notifications we get from the National Tsunami Warning Center. All of the areas in orange are under the purview of the Pacific Tsunami Warning Center. And that includes Hawaii. It includes Guam, Samoa, Puerto Rico, so US territories. They all get sent separate bulletins, and 40 countries elsewhere in the Pacific that have agreed through UNESCO and the International Oceanographic Commission to get advice about tsunamis from the Pacific Tsunami Warning Center. So they have a huge area of responsibility. We get very different kinds of messages to national soil as opposed to foreign soil. So in the US states and territories, there are 4 products that the Tsunami Warning Centers issue, either PTWC or NTWC. The highest level of alert is a warning. And a warning means there is potential for flooding on land above high tide. There's also a potential for strong currents, and the response should be to move out of those zones, move to higher ground or inland. Now, we only have one level of warning, which is basically if we think the water is going to be more than 3 feet above the background or ambient tide, you're going to get a warning. Doesn't matter if it's 3 feet, 15 feet, or 40 feet. There's no difference today in terms of what that level of warning is. A lower level of alert is what's called an advisory. And that means basically waters may be between 1.5 feet and 3 feet, but more importantly, very strong currents. And those currents, even without a huge high water level, are quite capable of tearing apart docks ripping boats from mooring and causing a lot of damage to the near beach area and in harbors. We call that an advisory. Uh, then there's this sort of wait and see or a watch, which means an event has happened, but it's not going to hit you for a while, and we have time to analyze further whether or not it's a big problem. So that's a watch. And then by far and away the most common product issued is what's called an information statement, which just says an earthquake's happened, you might have felt it, but it's too small to produce a tsunami. Every day there are 3 or 4 typically of those that get issued by the National Tsunami Warning Center, usually for magnitude 4 to 5 earthquakes in Alaska, occasionally for earthquakes in California or elsewhere in their area of responsibility. Now, the information, these statements, although they may say you should evacuate, they can't order evacuations. Only local and state jurisdictions can actually order evacuations, get out of the coastal area, or state it's safe to come back in. That is the purview of local state government. Now, as I said, there are these 40 countries in the Pacific that also get guidance from the Pacific Tsunami Warning Center. And the product that is sent is called a threat. The US cannot tell foreign countries, this is an event you might want to evacuate for. What they can say is, there's the potential for of this large a tsunami happening, and you might want to consider evacuating, but it's up to you to actually make that decision. Okay, here is the complete matrix that tells you what our tsunami warning centers are going to do for any particular earthquake located basically in the Pacific or the Caribbean or the Atlantic that could affect US territories. I'm not going to go through it in detail, just to tell you that on this side is magnitude. So all these areas in green, small earthquakes, earthquakes of less than magnitude 6, basically, they're never going to produce a tsunami. By the time we get down to, this is right here is 7.1, and that's kind of the cutoff for the West Coast. Earthquakes smaller than 7.1, no problem with a tsunami. 7.1 or larger, we're going to get a bulletin. Now, what happened on July 20th was a 7.4. So we go across, and this is the West Coast, basically, that line. We can zoom in and see a whole bunch of gobbledygook, and then we can read the fine print. And what we learn is that a 7.4 means they're going to issue a warning for all coastlines within 250 miles, or excuse me, 250 kilometers or roughly 200 miles of the source. Obviously, that was not going to be a problem for us because we're a lot further away for this earthquake. Now, when these larger earthquakes occur, the tsunami warning centers immediately utilize a number of different tools. The first one is just the size and location and the type of faulting that an earthquake was. Then they've got detailed information about the shapes of coastlines and the sea floor, and they can predict how long it's going to take a tsunami to travel. All tsunamis travel at the same speed, whether they're big or small. The physics of the water movement, displacement in the water is going to be the same. And it depends primarily on the depth of the seafloor. They've also got coastal and deep ocean water level instruments, and it's useful to look at what happened in the past, historic data. Now, I've shown an example of what happened actually on July 29th data, but similar thing would have happened on the 20th. These are recordings from 5 deep ocean centers, these DART instruments. And on all of them, you can see the initial seismic part of the signal and then the longer period tsunami part of the signal. So by analyzing these kinds of records, they're able to make forecasts of when the first surge is likely to arrive at any coastal location, but more importantly, what the whole waveform might look like and what is the highest surge likely to be. Now, based on where that earthquake is and those protocols, warnings or advisories will be issued from breakpoint to breakpoint. I think I talked about breakpoints when I gave an OLLI talk on the December 5th earthquake. This is actually a slide from that talk because it really illustrates breakpoints. I consider breakpoints to be archaic, and 5 years from now, I expect we will no longer be using them. But right now, we still are following National Weather Service protocol that says between 2 breakpoints, the forecast, the alert level has to be the uniform. So this is what happened on December 5th, 2024. The initial estimate of the earthquake was 7.3, and that means a 250-kilometer circle for a warning. But unfortunately, it put the edge of it just above the Oregon-California breakpoint, border breakpoint. So instead of having this be exactly 250 kilometers, the warning went all the way to just south of Florence in Central Oregon. And similarly, with much worse consequences to the south of us, it took us just into northern Sonoma County, but the next breakpoint isn't all the way down here until Santa Cruz. So as a result, the entire coastline, including all of the San Francisco Bay Area, was put into a warning. I will be very happy to see breakpoints go by the wayside, but at the moment, that's what we have to deal with. We're dealing with a system which tends to overwarn the area. Okay, let's look at in detail at what happened on July 29th when the big earthquake happened. So over these 2.5 days, 101 different bulletins were issued by our 2 tsunami warning centers. That included 35 messages from the National Tsunami Warning Center to Alaska, US, Canada, West Coast, 42 messages from the Pacific Tsunami Warning Center to Hawaii and US territories, and 24 messages, it's actually more than 4, it's up to 46 countries that are now in UNESCO's IOC. That's a whole lot of messages to keep track of. And even though I kind of understand the system, sometimes I have a hard time following them all. Looking at just the initial messages, the earthquake, 4:25 p.m. The first bulletins by the National Tsunami Warning Center and the Pacific Tsunami Warning Center are issued 8 to 10 minutes later. And in both cases, that initial magnitude estimate is only an 8.0, a still big earthquake. Um, and the National Tsunami Warning Center only put the westernmost Aleutians into an advisory and pretty much said, we're waiting to evaluate. The Pacific Tsunami Warning Center immediately issued a threat message to Russia and Japan. Other areas were in a watch. By bulletin number 2, boom, the magnitude estimate has jumped to an 8.7, which immediately expands the area of which of potential tsunami concern. And suddenly, U.S. territories and Hawaii are at potential risk, and more countries are. Similarly, the National Tsunami Warning Center expands their forecasts. And by, 2 hours after the earthquake, the entire West Coast is put into an advisory, which says low-level threat to harbors and beaches. Many messages later, 7:17 a.m. on July 31st, the last cancellation is finally issued. I think it's easier to get a picture of what was going on by looking at pictures. So I've just done screen captures of the tsunami.gov website, which did not crash, thank goodness, this time, of what it looked like at the time these different bulletins were issued. So 4:35, first bulletin, and this combines both PTWC and NTWC. And you can see there's the earthquake centered here. The purple balloons show the area that got threat messages. The orange is the area of advisory in the Western Aleutians. And at this point, Hawaii and Mariana, the Western Marianas and Northern Marianas and Guam are under a watch. Note over here, there's no colors on the US West Coast because in this particular bulletin, MTWC said, we've still got enough time to get more information. And that information is updated in the second bulletin roughly a half hour later when that magnitude is boosted up to 8.7. The earthquake was always the same size, but it's just that our instruments often tend to underestimate really big earthquakes. And you'll notice that the area that had been over here in the Western Aleutians under an advisory have now turned red. In other words, they're at risk of the tsunami is likely to be a little larger there. And it's now expanded into the Eastern Aleutians and you can see we've got colors everywhere here. So the Central and Eastern Aleutians are now in an advisory. All of this stuff in yellow means it's a watch. Watch just means that there's a good chance we could be raising and giving you a real alert level. And by now, all of Hawaii, they're still in the watch down here, but you can see the purple dots are now going further. Bulletin number 3. And for some reason, they've changed the way the screen looked because all I've done is just captured the images from their website. And at this point, you can see that a warning, Hawaii has gone into a warning. Things have stayed the same up here in the Aleutians, except for the Alaska Peninsula, most of Alaska, Southeast Alaska. They've now decided it doesn't have a problem. Don't worry, you're okay. But the entire West Coast has now been put into an advisory, all orange there. And again, the purple dots have pretty much stayed the same. This is now 4 hours after the earthquake. Bulletin number 5. Magnitude is now up to an 8.8. And this is the point at which Cape Mendocino to the Oregon border goes red. That's the point at which we are placed in a warning. The rest of the West Coast remains in an advisory, but we're in a warning, meaning potential for water heights basically more than 3 feet. This is a really busy illustration, so I'm going to kind of walk through it because I think it gives a better perspective, certainly from the potential of Crescent City, of what is going on. So this undulating line is the predicted tide. So high tides, low tides, too low, too high every day. And it turns out the tide's important because a tsunami basically rides on top of the tide. And so a 3-foot high tsunami at high tide is going to have more potential for flooding than a 3-foot tsunami at low tide. Here is where the earthquake occurs at a high tide over there in the northwestern Pacific. And this bottom line is the difference between the tidal variation and the actual water level. So the bumps here, swells, surf, etc. So you can kind of see it makes sense. It's right about 0 when you subtract the tide from it. The earthquake happens, and the very first bulletin is issued about 10 minutes later. And at that point, for Crescent City and the entire West Coast, we're not in any kind of a warning yet. This band at the bottom is when we actually have official alert levels. So we have the watch is the yellow. At 6:27 p.m., the orange becomes an advisory. At 8:27 p.m., we're in a warning for 12 hours. Then we're back to an advisory all the way to 7:17 a.m. when everything finally gets canceled. We actually have a real tsunami, which you can see by the red oscillation on the upper graph, which is the tsunami plus the tides, and the purple oscillation on the lower graph, which is just the tsunami. So the first tsunami arrival is just after midnight, 12:24 a.m. And you can see that the water goes up. There's a fallacious myth that goes around that says tsunamis are always preceded by the water going down. It's 50-50. So half the time the first wave will be positive, half the time the first wave is negative. Don't wait to see that first wave go out. And then you can see that the first oscillation is not the largest. It continues to go up and down. Our highest actual water height, not surprisingly, is on a high tide. But it's not the real, this is a larger amplitude, but the real highest water is actually a whole tidal cycle later because the tide's a little higher at that point. So even though the tsunami isn't quite as big, water height is higher. So this is why you need to stay away for a long time. So what happens when a tsunami warning is actually issued? Well, we learned on December 5th, 2024, that it activates the wireless emergency alert system. That was the first time that it happened in the contiguous 48 states. It had happened before in Guam, I believe. But it was our first experience and it was a rude one. So immediately, everybody's cell phones get this alert that a tsunami warning has been issued. Waves and currents may impact coasts near you. And then the words, "You are in danger. Get away from coastal waters, move to high ground." Note the emergency alert system and WIA are not activated when you're in an advisory. So, an advisory is a much quieter kind of event in terms of being able to handle public response. Here's a quick overview of what seems to have gone quite well in the July 29th event as far as the tsunami warning system worked. The messages were issued and disseminated in a coordinated and timely fashion, following protocols. Those 101 messages all got out there. Some of us think there might have been a few too many. But the messaging worked the way it did. Please keep questions. Can people please, can you mute your phones while I'm doing my presentation?
But how do I turn it off? What's
Please stop talking. I need to get through this. Thank you. The WIA alerts arrived within minutes of making that warning decision, which was the way the protocol states. The forecasts of the peak water height were spot on. I mean, the nice thing about earthquakes far away is that you have time to get data, refine models, and the estimated water heights were very close to what they were actually measured. The websites did not crash, which they have done in the past. The tsunami warning centers held regular conference calls with constituents, basically state and county emergency officials. There were no deaths, there were no injuries related to the alerts in the United States. That wasn't true everywhere. Fortunately, the discussions were such that the San Francisco Bay Area was kept out of the warning zone. According to strict protocol, they should have been included in the warning, but thank goodness people had better sense. And humans still do a better job of making those kinds of decisions than artificial intelligence. Always wonderful when the source is 8 hours or more away from us, because there's time to really further assess it. The biggest area for improvement has to do with over-evacuation. And the reasons for over-evacuation are partly structural and partly human, the way we tend to respond. So the tsunami, as I said, first of all, we have the breakpoint issue was one of the problems because we have to have a uniform warning between the Oregon border and Cape Mendocino. It turned out all of the modeling for this area was 1 foot or less. And it's not until you really get into Del Norte County and particularly Crescent City where you're looking at 3 to 5 feet, which puts you into that warning. There was one exception, and that is the modeling for Trinidad Head suggested maybe 3 feet. So borderline. And unfortunately, the people at the Tsunami Warning Center don't realize that nobody is right on the beach at Trinidad Head. there really is no exposure there. So it was unnecessary that most of Humboldt County, well, that all of Humboldt County was placed in a tsunami warning. I don't know if the next things are going to be corrected before the next tsunami hits us, but it's important to understand that although the warning level may be uniform, the threat level is not. Notice on this particular map, the pink areas are what were shown by the tsunami warning centers as being the area of hazard. Now, some of these elevations in here are over 1,000 feet high, and we don't have a tsunami threat here. And on the right, you can see the actual state map. The areas in green are safe for our biggest event, magnitude 9 on the Cascadia subduction zone. And you can hardly see these yellow areas that are at risk. Here I've blown up Del Norte County, which has the greatest tsunami hazard in our area. And you can see how these pink Weather Service maps greatly exaggerate the area at risk compared to our state tsunami maps. Why do we see these exaggerated maps? It's because the tsunami warning centers, as part of the Weather Service, can only disseminate a Weather Service product. They cannot disseminate a state product, even though it's been much better vetted. And the tsunami centers have no tsunami product for hazard mapping. They rely on the states to do that. What they do have is the weather zones. So all they've done is just grabbed the weather zone map and colored it all in as being the tsunami hazard. So this is something which is really hard to combat in the moment and tell people, no, don't look at those maps issued by a trusted government entity because they're actually not correct. Please look at the state maps, which are. And that's one of the things I hope everybody does for Tsunami Week. So this structurally imposes over evacuation. The WIA language that says you are in danger. Now, the way WIA currently works, it doesn't target just people in coastal areas. Any county with a coastal coastline will get this message. So Willow Creek, you might get this message. And you are in danger makes it sound pretty scary. Fortunately, new language has now been finalized. It should get approved this week, but there have been a lot of delays. They've removed the "you are in danger." Now it just says waves are expected to flood low-lying coastal areas. Of course, they don't tell you what low-lying coastal areas are. It's a slight improvement, but it's really still important for people to understand their tsunami threat, where they live and where they work. Because if you are in a safe area, it's actually hazardous to evacuate. There were a lot of problems, particularly in the Valley West area of Arcata, where there were, it's the middle of summer, lots of tourists in hotels. They get this alert. And so what do? They immediately get in their cars, try to evacuate, massive traffic jams. And in fact, it actually delayed the ability of first responders to access accidents that had occurred before the alert. So evacuating by car is never a good idea because half the people who died in the Japan tsunami died in their cars because they were stuck in traffic jams. And in many cases, walking 10 minutes would have taken them out of the tsunami zone. So some post-event assessments. This is a detail of the kind of source rupture area and these communities, Severokurilissk and Petropavlovsk. Petropavlovsk, city of 160,000 people, is a very modern city built to modern construction requirements, and the damage was surprisingly modest. There was minor to moderate damage. There were no structures that collapsed. There were no deaths due to shaking. There were 4 injuries reported. Might have been a few more, but we're really talking about a non-event as far as shaking was concerned. There were certainly disruptions to power. It affected the power grid, electrical ventilation systems, disrupted communications, all those things that you would have expected. Severokurilissk had more damage, really closer to the strong shaking area. And many chimneys toppled, damage to, again, minor to moderate damage to structures, but again, no injuries reported. Now, the tsunami was big. These numbers here are in meters. So 19 meters is close to 60 feet high. We're talking about a big tsunami. Fortunately, the areas where the largest tsunami heights were recorded, there are basically no people. So here's some satellite views showing before and after in Vestnik Bay, and you can see how the vegetation has been stripped away in a large area. Back to Severokurilissk, there was certainly damage in the harbor. This is actually a Russian submarine station. We don't have a whole lot of detail about what happened, but there was some damage to those facilities. In the far field, the tsunami was relatively modest. The highest water levels were recorded in Hawaii, 1.74, and Crescent City, 1.24. Again, those are in meters. There was no direct tsunami damage in Japan. However, the only person who died related to this tsunami was in Japan, and that was related to a panicky evacuation where a woman was driving too fast and drove off a cliff. So again, there are risks associated with evacuation. 21 injuries were also reported in Japan. This was a horrendous heat wave, and people were exposed in evacuated areas without enough water, without enough shade, and those 21 injuries were related to the extreme heat. So there were more injuries, and the only death in Japan, which had 0 tsunami damage, than in Russia. In Hawaii, relatively minor damage, minor flooding, but a lot of confusion, massive traffic jams, and a big hit in the economy because of lost tourist dollars. On the West Coast, there was a bait barge that broke at Dana Point down here. And the other damage was about $1 million in damage to Crescent City's H-Dock. And probably 5 times that much in terms of having to dredge those sediments. What is so special about Crescent Harbor? Why, when Crescent City is so far away from the tsunami, does it time and time again seem to have the largest surges and the most damage? Well, Here are 6 reasons. The first is a kind of oh duh reason. Exposure. Low elevation, the land projects into the ocean. Most of the rest of the West Coast is much higher elevation. So just the fact it sits out there and is low is our number one reason. The second reason has to do with the shape of the seafloor. A tsunami, unlike normal ocean waves and swell, affects the entire water column from the seafloor up to the sea surface. And the shape of the seafloor can focus and diffuse, can slow, can impede or speed the progress of a tsunami. And as a result, Crescent City has got the deluxe road that really focuses tsunami energy in that particular spot. There are a variety of things in the far offshore seafloor topography that account for that. But it's not just the far offshore, because that affects Humboldt County as well. Near offshore has to do with the shape of the continental shelf. So the continental shelf off the Northern California coast is a little bit bowl-shaped, which means once you get the tsunami onto the shelf, it kind of rattles around. It oscillates with a fairly long period offshore. So unlike what happens in Hawaii, Hawaii is kind of cone-shaped, and the tsunamis come in and the first few waves are large and then they very rapidly die off. On the California coast, energy gets trapped on the continental shelf. So rattling back and forth for days. But it's not just the continental shelf, but also the actual shape of the coastline. So the deeper the water, the faster the tsunami travels, and the way the Del Norte County coastline is shaped, that pretty much any tsunami, whether it's coming from northwest or south, gets wrapped around and swung in to the harbor area, sort of focused. Now, the harbor itself also exacerbates the situation, because this crescent-shaped harbor, even before the seawall was built, has its own set of oscillations back and forth, that interfere with the signal coming from the far offshore and the near offshore. And then finally, if we really want to add insult to injury, in the 1970s, when the Citizens Dock was built, it was designed in such a way that it really amplifies tsunami energy with that narrow mouth, hard walls, rectangular shape. It just, I did a study a number of years ago, and we showed that the amplitudes inside Citizens Dock were roughly 6 times what they would have been had that dock never been built. Crescent City is the poster child for tsunamis lasting a long, long time. So what I've shown here is the entire merogram for a couple weeks. So here's before the tsunami, the arrival of the tsunami, and then this is the point at which the advisory was canceled, right there. So that's our 2.5 days. And then we still have a number of days where the currents in the harbor are still too strong to be able to get into the water. So tsunamis can last a long, long time. So what have we learned since this event? Well, we've had aftershocks, and some of them, the largest was a 7.8. It also triggered tsunami threat messages and produced a modest tsunami that was recorded in Crescent City. No surprise. why wasn't the Kamchatka tsunami more damaging? Okay, it was big. I showed you it was nearly 60 feet high in the southern part of the Kamchatka Peninsula. And yet it did relatively little damage. What I've shown on this slide is a comparison of two models done by NOAA's Tsunami Research Center. Thank you, Vasily Titov, for sharing these, with the same color ramp for the 2011 Japan tsunami and the 8.8 Kamchatka. Now you notice they're in different positions and there's a different orientation of the fault. In both cases, we have amplification on our coast. You can see it's red, it was a lot bigger back in 2011. And you can see these fingers of energy. Well, fortunately, one of these fingers just bypasses Hawaii. So again, the shape of the seafloor. So smaller earthquake is part of it, but the unique characteristics of this particular source were pretty much why we dodged a bullet. Mitigation efforts in Russia really paid off. Well-engineered city, Petropavlovsk. Severokurilisk rebuilt on high ground after 1952. But that's not all they've done. They really take emergency response training, education, outreach, and the cultural memory of what happened in 1952 are really important. Pacific tsunami mitigation efforts paid off. These deep ocean DART instruments almost all worked. The important ones, enough of them worked. They're all in remote areas. They can't be easily serviced. And so we're very fortunate, especially for those of us on the West Coast, got very precise estimates of how high the water was likely to be. This forward modeling was terrific. The expansion of participants in UNESCO's IOC tsunami program, which includes the International Tsunami Ready program. Again, recognizing it's not just having a notification system, you've got to train the people who receive it. Effective assessment and dissemination of the tsunami threat. And it was really good that only a little bit of our coastline ended up in a warning, as opposed to the great long swath that happened in 2024. I've been really impressed by some of the new space-based techniques that we're seeing maybe closer to fruition. Two satellites recorded very different aspects of this tsunami. One of them is what's called NASA's SWOT satellite, the Surface Water and Ocean Topography. It's one satellite that's orbit is such that over a 20 or so day cycle pretty much covers all of the planet's oceans. And it maps a 75 foot wide swath, 75-mile wide swath that gives incredibly detailed picture of what's happening on the ocean surface. And this little swath shows what was recorded on July 29th, where it happened to fortuitously be just off the coast of Kamchatka. What it shows is that the tsunami is far more complex than what we had believed before. That has not been included in tsunami models because we can't see the darn things that well by single instruments, even if we have a lot of them. So this is really changing kind of our perceptions of the complexity of in a tsunami wavefront. And it also suggests from this data that the sources of the tsunami was actually larger than the earthquake sources. It was a larger area of deformation than what we see from the seismic data. Over here on the right is the NASA Guardian satellite, the GNSS, Upper Atmospheric Real-Time Disaster Information and Alert Network is what that stands for. And it measures waves in the ionosphere. So what does the ionosphere have to do with the ocean? Well, when a tsunami travels, it actually effectively lifts the entire air column above it, including the ionosphere. And this data is actually available in near real time. I mean, 20 minutes after the earthquake happened, this graph was basically available. And the hope is to eventually incorporate this into tsunami center modeling to provide us with a more precise, a new piece of data on what the tsunami is actually doing. Plenty of lessons for those of us in the Cascadia region. We may be far away, however, we're certainly susceptible to a similar magnitude earthquake, large rupture, long duration, producing a significant tsunami. There are really big differences. So the Kamchatka environment, it's a much older subducting slab. It's converging at a much higher rate. It has a larger dip angle. Many earthquakes in our so-called interseismic phase. Cascadia, stone cold quiet since, basically since the last great earthquake over 300 years ago. And much larger population exposed here. But what worked well in Kamchatka is worth considering for Cascadia. Strong building codes, moving vulnerable structures out of the tsunami zone, cultural awareness, and support for emergency management and drills. I would really like to see us pay more attention to studying potential foreshocks. Is it possible to understand that better, and could that provide some guidance to emergency managers? Say we had a 6.5 on the subduction zone interface, like we had in 1954. Fortunately, that did not prove to be a foreshock, but how would we respond to an event like that? So, kind of in summary, we have three general categories of tsunamis that can affect us here on the North Coast. Over here in green are what happened on July 29th, or Japan, 2011. Very large earthquakes from far away, where our tsunami warning centers can analyze it. We've got only 4 or 5 hours from Alaska, but there's time to really assess what we're looking at and issue official warnings and get people to evacuate out of the area at harm's way. Then we have very large earthquakes on the Cascadia subduction zone. Maybe the whole thing ruptures, maybe only part of it ruptures. Those are going to produce bigger tsunamis. And then finally, we're going to have what happened on December 5th, where we have large offshore earthquakes in the 7 range that will trigger a warning, but will very rarely produce a large tsunami. So down here at the bottom, this was from my last column, you can kind of imagine this whole spectrum of tsunami events. And obviously there are more in here too. We have the great earthquake far away that could produce, in the worst case, something like what happened in Alaska 64. So certainly potential to do quite a bit of damage, but not nearly the amount of damage as putting that big earthquake right here. And that's why all of our tsunami maps are based on this worst case. So in between, major earthquake far away, in the 8 range, 2006, one of those destroyed much of Crescent City's harbor. Major earthquake nearby, maybe a partial rupture of the subduction zone. We don't really know what that's going to look like, but it certainly could be significant. And then the most frequent is probably the least threat, the large earthquake nearby. But all of these are encompassed within our current tsunami maps. We do not need to evacuate areas outside of the tsunami hazard zones on those maps, even for our worst case event. So thanks to all of my colleagues, all the organizations, thanks to OLLI. And if there's time for a few questions, I'd be glad to take them.
Well, first of all, thank you, Lori, for putting all this together once again for us. It's always so informative and we incredibly appreciate it. And there were a couple of questions. What does reverse northeast mean?
Reverse? No,
That was way back when.
okay. We're talking about the source of the Kamchatka earthquake was a 250 to 300 mile long rupture that was oriented north northeast, south southwest, and it's what we call a reverse mechanism. In other words, the Pacific plate was diving beneath the North American plate. That's what we call reverse motion. It was actually a thrust.
I remember really well when people were panically trying to get out of Eureka.
Back in 2024. Yeah.
Yeah, I mean, it was a mess.
Right.
I presume that's being worked on more urgently.
Not really.
Really?
Because the main thing is education, and our education funding has been cut way back. So we have less than a half of the funding that we had received for outreach efforts over the past decade now.
Well, then you need to continue giving talks as you do.
I
do a lot of them.
Yeah, I've had to stop doing our daily earthquake updates. And yeah, one can only do so much for gratis.
I know. It's a problem. I mean, we do as much as we can pull off, but sometimes there's way more than we can manage to tackle. And people in this community do volunteer so much time and effort and expertise, and it's wonderful that we do, and it's wonderful that you do. And I'm glad you're being finally recognized by the league. It's about time.
They're a great group.
You've been magnificent. Does anybody else have any other questions that they'd like to ask at this time? If so,
I have a question.
who's that?
Sherman.
Oh, go for it.
Oh, go for it, did you say?
Yes.
So the map that you put, or the chart that you put up with the superposition of the earthquake wave over the regular tidal wave, could you put that back? It's the first one you did. It was big.
I have there's no earthquake waves. You mean
Okay,
the dark?
it's a tsunami wave superimposed on the tide.
Oh, okay. That was, okay. Let me just see if I can.
Yeah, that was very interesting because
Yeah.
it clearly showed that they stopped the warning at way too prematurely.
Right, I was going to ask about that.
Well, no, they didn't stop it prematurely. They actually, whoops, okay, there we go. And actually, let me get out of that for a minute and get that slide particular. Okay,
It's not that one.
Yeah, it's not this one. It was the one higher up, I think.
Right.
Earlier one. This one.
Yeah, over there. You got it.
Okay.
So
Yeah, that's the one.
You pointed out that the water was actually higher up here, but they've already.
Yeah, this is the actual highest water. So, and then I can go back to that other one that has the full thing. First of all, there are tsunamis that happen all the time, that we record all the time, that no alert is issued for because they're too small. So once the water, the amplitude is less than about 1.5 feet, we can record it still. It's not going to cause damage to structures in ports. And so the tsunami warning is canceled at the point basically where we think the currents are going to be below that threshold. Now, there is a caveat in Humboldt Bay in that we sort of issue an unofficial alert to the harbor master when there is the potential for even a modest tsunami that coincides with a strong ebb flow. And we saw this happen. We had a magnitude, I think it was 8.1 or 7.9 from Alaska in July of maybe 2021. I may be off a year or two by that. And a good friend of mine, Donald Forrest, who has since passed, was exiting the bay, going through the channel, when suddenly insane currents jerked them from side to side. And there were at least 3 or 4 other boats that experienced the same thing. And that was actually because this very modest tsunami was incoming and interfering with the very strong outflow through the channel. That's no reason to issue a warning because areas outside of the channel had no risk at all. You wouldn't have seen any tsunami, but it's important for, I mean, any mariner going in and out of the Humboldt Channel needs to understand it's the most hazardous crossing on the West Coast, with the exception of, I guess, the mouth of the Columbia. But you need, I've told everybody, even if a magnitude 7.9 earthquake has occurred in Alaska and there's no tsunami advisory in place, it's still not a good idea to go through the channel on a strong ebb tide. So there are always local exceptions. But just because you still see a tsunami on the signal doesn't mean that it's actually hazardous for normal kinds of conditions. And that was what this one was showing.
If I could just make a comment, we were in a boat off of the Aleutians last summer, not this earthquake, but there was a deep sea earthquake there. The captain took the ship out to deep water because there
Yes.
was a tsunami warning.
Yeah. Well, that is the protocol. And that's exactly what happened in Crescent City on July 29th. About 2/3 of the commercial fleet did leave the harbor and they stayed out for quite a while. And it was fortunate because it was a very calm day, very pleasant conditions on the ocean, safe there. But about 1/3 of the boats did not leave. Fortunately, the modifications done to the harbor after 2011, H dock. It's a very large dock that when you immediately enter the harbor, it had been specially designed to dampen tsunami waves. And it did its job. Unfortunately, it sustained $1 million worth of damage, which was not intentional. They'd hoped that they had designed it so that the dock could adjust its height, float up and down as this water level changed. But unfortunately, the currents were too strong and pinned the dock against its support, and that's what caused the damage.
Suzanne has a question. Is there a magnitude 9 earthquake in the Cascade subduction zone? Or if there is one, what size waves might we expect here and how much notice might we get?
I'll start with the end of it. And the notice is you will get none from the Tsunami Warning Center. None. And the reason for that is that this earthquake, the rupture is 8 miles beneath your feet. I mean, that's where I'm assuming you're in Humboldt County. If you're anywhere in Humboldt and Del Norte County, basically that rupture is right beneath your feet. It's a 650-mile long rupture that extends 40 miles offshore, extends inland to Willow Creek. Huge rupture. And that rupture, unlike what happened in Kamchatka or even in Alaska, we're much, much closer to it. In fact, we are the closest population center essentially anywhere in the world that sits on top of a major subduction zone. Most subduction zones are offshore, 50, 100 miles offshore, and the whole rupture is offshore. But we're sitting on top of it, and we have lots of secondary faults that spin off of that rupture zone. A number of which cut right through our land. For example, the Eureka Arcata Airport sits right on top of one of those secondary faults, capable of producing a 7.7 earthquake in its own right. The Little Salmon Fault that the Tompkins Hill gas line crosses in 6 places. Again, capable of producing a 7.8 earthquake on its own, probably related to Cascadia events. The amount of damage from ground shaking in that magnitude 9 will likely cut us off from any form of communication. We'll survive because we have the kinds of buildings that don't collapse in strong earthquakes, and most of our structures are relatively low, less than 3 stories and so forth. But I will be amazed if we have any communications at all within the first half hour of that earthquake. And afterwards, hopefully we'll have some satellite communications, but we'll certainly have no advice from the Tsunami Warning Center. But what you will have is more than 3 minutes of ground shaking. And there will be no question in your mind that, whoa, this is what Lori was talking about. Even if the shaking is not super strong, because we don't know how fast the rupture will be, could be a relatively slow rupture, but it will go on and on and on. And that is your warning. That is your warning that you need to know if you need it. You live in a tsunami zone. If you're out of the tsunami zone, you're just going to check on your own home and make sure that you don't smell gas. If you do, you turn the gas line off. If you don't smell it, leave it on. And be prepared to ride out the next 2 to 3 weeks, because it may be that long before you can get groceries or anything. If you are in the tsunami zone, that is your clue to grab your grab and go kit, grab your kids, put the dog on a leash. Don't worry about the cat if you haven't trained it to get into a cat cage immediately when the ground shakes, and immediately go to your pre-designated safe area outside of the zone. Those first surges could arrive in as little as 10 minutes.
Okay, any other questions? Then I want to thank you ever so much, Lori, for fascinating us once more and helping to inform. You've done great work, and I'm delighted to have you back every time you want to come. We're happy to have you.
Well, you're my favorite audience.
Well, we love to have you. And I think you have a lot of friends in this audience.
Hopefully.
Yeah, just a few. I want to let you know that next week on March 30th, we have Bruce Kessler, a retired internist with whom many of you are familiar, on why is it so difficult to obtain medical care in Humboldt County, and that speaks for itself. I think many of us are aware of that problem somewhat continuously.
Yeah,
So we look
Bruce
forward
is
to
my
seeing you back.
doctor. Bruce is my doctor and a very good friend, and
I know he attended this today.
Oh, hi,
But
Bruce.
he's disappeared. He probably had to go to work, except actually he's retired. But anyway, thank you ever so much, and we look forward to seeing you all next week. Have a wonderful week. It's been gorgeous. Happy springtime to everybody.
Thank you very much, Laurie.
Thank you.